Across rapidly industrializing hubs like Kunming, China, the demand for a specialized workforce is constant and urgent. The modern apprenticeship system is designed to meet this need by integrating classroom theory with workplace experience, creating a workforce capable of adapting to shifting industrial requirements. On the surface, the system appears highly effective. Institutional data shows high rates of structural implementation and student satisfaction scores that are overwhelmingly positive. However, these high marks mask a persistent issue: significant skill mismatches that surface the moment graduates enter the labor market. Traditional administrative metrics like graduation rates and basic program satisfaction are failing to detect the internal friction within the training pipeline. Relying on these top-level satisfaction scores creates a deceptive picture of health, proving that standard evaluation frameworks cannot accurately diagnose why graduates are struggling to meet market demands. Diagnosing this gap requires a new analytical lens. We have to look at the system through the model of learning ecology. This approach views an apprenticeship not as a static checklist of syllabus items, but as a relational ecosystem where learning is co-constructed between the student and their environment. This ecosystem is mapped across 4 dimensions: the personal, the social, the cultural, and the physical or process dimension. Administrators often treat these as equal priorities, assuming that investment in physical equipment, like a new lab, is just as influential as the surrounding institutional culture. To address the skills gap, we must move beyond descriptive metrics. We need to map the actual hierarchy of this ecology and engineer targeted institutional interventions. By moving from a flat administrative view to a hierarchical ecological diagnosis, we can identify the specific structural barriers preventing workforce readiness. Using data from 438 apprentices, we can isolate the specific factors that drive the perceived success of a vocational program. A linear regression analysis was conducted to measure how much weight each ecological dimension carries in determining overall program effectiveness. The results reveal a clear hierarchy. The variable for perceived industry recognition accounts for an overwhelming 90.2% of the variance in perceived success. This means an apprentice's confidence in their education is dictated almost entirely by whether the external labor market recognizes and values their credentials. The second strongest predictor is the apprentice's attitude toward the dual mentor system, which explains 75.1% of the variance. This integrated mentorship framework serves as the primary engine for connecting classroom principles with the concrete realities of the job site. In contrast, the internal factor of professional theoretical achievement accounts for 57.2% of the variance. While theoretical mastery remains a significant component, the regression shows it is a secondary driver. The ecosystem's overall effectiveness is more heavily influenced by market credibility and social mentorship. To see how these classroom objectives align with workplace reality, we have to examine the internal mechanics of the school-enterprise relationship. The Pearson correlation matrix in Table 1 allows us to map the interdependencies between these ecological factors. A specific quantitative anomaly appears when we compare theoretical knowledge with practical skill. Between professional theoretical achievement and professional skill proficiency, the data shows a weak correlation of only 0.291. This indicates a loose coupling between knowledge and application. Mastery of classroom theory is only a weak statistical predictor of a student's actual performance in the workplace. This reflects a reality where an apprentice might excel in complex exams, while their practical internship is limited to menial tasks that are entirely disconnected from the curriculum. Theoretical achievement also showed the highest standard deviation in the set, pointing to wide disparities in how foundational knowledge is delivered across different institutions. This weak correlation identifies a structural imbalance. It points to a gap in the training pipeline where schools and enterprises are failing to effectively translate theoretical learning into practical capability. By turning to qualitative insights from 48 stakeholder interviews, we can identify exactly why this pipeline is failing. The first root cause is insufficient institutionalized collaboration within the dual mentor system. Currently, cooperation between teachers and mentors depends on ad hoc personal connections rather than formalized institutional protocols. This fragmentation leads to misaligned goals. Schools prioritize broad theoretical coverage, while enterprises focus on immediate operational efficiency. The second root cause is a cultural and physical misalignment between the classroom and the factory floor. 41% of students are trained on outdated equipment, and academic curricula frequently lag years behind the technological advancements found in the industry. When collaboration is left to personal initiative rather than structural design, schools and enterprises remain in silos, and the skills mismatch persists. To resolve these imbalances, the system must move toward a four-pillar architectural framework designed for institutional integration. Pillar 1 is the institutionalization of the dual mentor collaborative engine. This involves mandatory bi-weekly co-planning sessions and a unified digital log to track student progress across both the school and the workplace. Pillar 2 focuses on establishing a dynamic, industry co-designed curriculum. By mandating that senior technical experts from industry serve on curriculum committees, schools ensure their learning processes are informed by real-time technological standards. These first two pillars address the social fragmentation identified in the data, replacing informal cooperation with a sustainable institutional structure. The final pillars address the cultural and informational barriers that impact market credibility. Pillar 3 is the co-construction of regional skills standards. Vocational institutions and leading enterprises must collaboratively publish quantifiable competencies, like specific precision tolerances, ensuring that student credentials have clear market value. Pillar 4 involves building a digital ecosystem platform to manage resources and transparency. This infrastructure provides a centralized hub for pedagogical resources and policy frameworks, reducing the informational gaps that undermine trust between stakeholders. Sustainable workforce development is the emergent property of a strictly coordinated learning ecology, not the result of a single isolated policy. To secure the future of industrializing economies, educational leaders must transition from managing discrete programs to proactively steering the entire training ecosystem.